So just like many other parts of my course, we're going to start with this initialization code. I have references if you want to refer to any of it. The main things that are going on here is we're detecting the type of acceleration device that we have. I'm running this in Colab, so we're using CUDA. And I define an early stopping function. This is, or class rather, it's passed into the PyTorch training loop, and as soon as the validation set fails to improve up to the patient's value, it stops. So that's early stopping. You can refer to 3.4 for that. K-fold cross-validation, what it's doing is we break the data set into some number of folds. In this case, we're going to break it into 5, but it could be any number. 10 is also really pretty common. For each of these folds, we're going to take the entire data set, and we're going to take one segment of it. So we're breaking the data set, this data set up here, we're breaking it into 5 equal parts. They may not be exactly equal due to the fact that not all numbers are divisible by 5, but we get close to that, and we're going to pick one of these folds becomes the validation set that you're using to tell when the training set is no longer improving, and you can go through all of these. What this allows you to do then is you can, after it's done training, you can use the validation set to generate a out-of-sample prediction. So you predict these values, and then you concatenate all of these yellow parts together, and now you have a complete out-of-sample prediction. Now, I will point out one caveat here. If you are using the validation as part of for your early stopping, technically you are blending your training and your evaluation a bit, and some people will be against that. I have used that in what I'll do if I'm really concerned about polluting my pure validation is I'll just take a holdout out of this whole thing at the beginning and use that for final validation. And of course, you are going to get 5 different models from this, so you're really testing overall your overall training process rather than one specific model. And this gives you then a whole out-of-sample prediction. So let's go ahead and make use of this. We're going to use really 2 different approaches. We're going to use a k-fold cross-validation when we're dealing with regression data, and a stratified k-fold when we're dealing with classification problems. That takes the class into consideration and eliminates any sort of bias according to the class. We're using my sample data set that we've seen before. This is really just a completely somewhat randomized data set that has categoricals and continuous values in there. We are simply going to use this initially to do a regression job. So we're going to try to predict one of the continuous values on it. Now that we've loaded that data set, we are going to break it into the X and Y, just like we did before. We're going to try to predict the age value based on the others. Just an arbitrary selection for the target. I designed that data set so that there's potentially multiple values that you can use for your target if you so desire. And then we begin training it. Notice that we're using the k-fold split. This is from here. This is coming from scikit-learn, and we are saying to shuffle it. So it will shuffle the items, because who knows, there might be some bias or information baked into the order of it. We don't want to use that information if it is, because the order of, this is not time series. If the order of the data means something, you have a problem. We create the data loaders and then define the structure of the neural network. This is a fairly simple neural network, 20 hidden neurons in the first layer, 10 in the second. We compile it for maximum performance, and we're going to use the atom optimizer to train it. So we're going to go through each fold, and then we're going to go through the actual epochs that we've gone through before. And I've got it running in the background while I explain it, because this does take a little bit to go through all 5 of those. The usual sort of training is done. We are going to loop until we hit the number of epochs. We put the model into training mode and loop through each of the batches where we are zeroing the gradients because it's a new batch update. And then we present the model, calculate the loss. This is the training loss. Backwards propagation to get the gradients, and then we let the optimizer update the weights in the neural network based on those gradients that we found. For the validation, we flip into eval mode and we validate it with the test data set, the validation data set. We calculate our loss, and that's our validation loss. We check with early stopping if we are done with this fold because the error is no longer improving. And you can see the results here. The various folds, you'll see that there is some variation in the validation loss. It's really just luck of the draw of which data got put into each of those folds. If you're seeing one fold particularly have a bad validation like you have here, that means it's a smaller-ish data set, which this is, and there's some extreme outlier, and whichever fold ends up with that outlier in there is quite unlucky, and we'll get a worse score. And then we are going to deal with classification. So for classification, we're going to load exactly the same data set again. That's all the same as before. We're going to create the model, except this is softmax because it is classification, and we are going to use now the stratified k-fold. So that ensures that it stratifies the data to eliminate too much disproportion according to the class that we have. We're going to use cross entropy and atom. And this code is all pretty much exactly the same, except that the structure of the neural network was different. So I'm trying to give you boilerplate code, both for a classification problem and for a regression problem. All this works exactly the same. We are calling on the early stopping right here, and if early stopping states that we're done, we're done. You can see there was not a particular outlier. The validation sets, the scores are really a lot more similar, and you can see they all stopped at 5 epoch when they detected that. So that's cross-validation for PyTorch. If you found this video useful, please give me a like and subscribe to the channel so that you don't miss anything with this course as we go through it. Thank you very much.